Hi guys. So today we're going to look at evaluating with inverse trig functions. So we're going to look at finding actual values using the inverse trig functions. In order to do that, you first need to know the trig values of your special angles. If you don't already know those, you need to have those down, or at least have your chart there and ready to go. You also, remember, should know 0 degrees is 0 radians, 90 degrees is pi over 2 radians, 180 degrees is pi radians, 270 degrees is 3 pi over 2 radians, 360 degrees is 2 pi radians. Now sine, if you remember from your graph, the sine of 0 is 0, the sine of pi over 2 is 1, the sine of pi is 0, the sine of 3 pi over 2 is negative 1, and the sine of 2 pi is back to 0. Cosine, remember, starts at 1. Cosine of 0 is 1, of pi over 2 is 0, the cosine of pi is negative 1, the cosine of 3 pi over 2 is back to 0, and the cosine of 2 pi is 1. Now tangent, you have two options. You're either remembering your graph, or you remember that tangent is sine divided by cosine. So 0 divided by 1 is 0. 1 divided by 0 is undefined. 0 divided by negative 1 is 0. Negative 1 divided by 0 is undefined. And 0 divided by 1 is 0. So that's the first chart. The second chart, okay, this is with our smaller special angles in that first quadrant. 30 degrees, remember, is pi over 6 radians. 45 degrees is pi over 4 radians, and 60 degrees is pi over 3 radians. Those are the ones you should not have to take the time to figure out. You should know those. Now the sine of 30 degrees, or pi over 6, is 1/2. The sine of 45 degrees is radical 2 over 2. The sine of 60 degrees is radical 3 over 2. Remember, cosine is backwards, so the cosine of 30 degrees is radical 3 over 2. The cosine of 40 degrees is radical 2 over 2, and the cosine of 60 degrees is 1/2. The tangent, again, is still sine theta over cosine theta. 1/2 divided by radical 3 over 2. It's 1 over radical 3, but most of you learned it in its rational form, its rationalized form, radical 3 over 3. And tangent of 45 degrees, radical 2 over 2 divided by radical 2 over 2 is 1. And then finally, the tangent of 60 degrees is radical 3 over 2 divided by 1/2, which will just give you the square root of 3. So now we have the basics of our special angles. Now we can look at our inverse trig functions. Now before we actually start evaluating, I'm going to take a moment and we're going to look back at those inverse trig graphs and the restricted domain and range. I'd like to look at the range because the range, that's where your angles are. Remember, these are the angles. Okay, those are the angles. So when we're looking at sine inverse, the angles are going from negative pi over 2 to pi over 2. That would be in quadrant 1 and quadrant 2. And if we remember, all students take calculus. What we have here is we're using the angles from negative pi over 2 to pi over 2. In the first quadrant, from 0 to pi over 2, that's where the angles will give you positive signs. In the fourth quadrant, from 0 down to negative pi over 2, that's where the sign of the angles will give you negative values. Okay. Now, if we look at cosine inverse, again, we're going to look at this range. This time we're going from 0 all the way around to pi, because again, all students take calculus. However, we're using these quadrants because in the first quadrant, the cosine of a first quadrant angle is positive, but the cosine of an angle between pi over 2 and pi is negative. So if we're looking at a negative value, we want to be in the second quadrant. Whereas if it's a positive value, we're in the first quadrant. When it was sine, a positive value kept us in the first quadrant, but a negative value put us in the fourth quadrant. So that's where the difference is. And notice cosine is the only one that has that range. The only difference with the range on the tangent is you can't be these endpoints because tangent is undefined at pi over 2 and negative pi over 2. Okay, so we're still dealing with the first and the fourth quadrants. The difference is we can't be those quadrantal angles. All right, in the first quadrant, tangent of angles in the first quadrant are positive. Tangent of angles in the fourth quadrant are negative. Okay, now why did we go to the fourth quadrant for tangent instead of the second quadrant? Because tangent is also negative. The reason, here's our fourth quadrant angles. If we used the second quadrant, the graph would be up here. That's not a connected graph. And that's the reason. If we use the first and the second quadrant, our inverse graph would be in two different pieces. It wouldn't be a connected continuous graph. So they use the fourth quadrant and the first quadrant, so we get that nice, smooth, connected graph for tan inverse. All right, and we have two connected quadrants, 1 and 4, where tangent is both positive and negative. Now we're ready to actually do some evaluating. So here's the first one. If x equals the arc sine of negative 1/2, we want to find the measure of angle x. Now notice this negative. Sine is only negative in quadrants 3 and 4. We're not allowed to be a third quadrant angle though. So we're looking at quadrant 4. Now what's the reference angle? What angle has a sine of 1/2? What angle has a sine of 1/2? That would be 30 degrees, or the better answer, pi over 6. Now, if we're in that fourth quadrant and we're rotating down negative 30 degrees, that angle is negative pi over 6. And we prefer the radian answers, but yeah, it's the same. It's negative 30 degrees. So that's our answer for that one. Let's take a look at 4. If theta equals the arc tan of negative 1, find the measure of angle theta. So again, I'm going to ignore the negative. What angle has a tangent that is 1? Think back about your charts. What angle has a tangent that is 1? That's 45 degrees or pi over 4. See why these charts are important? Now we're going to say, okay, in which quadrant can tangent be negative? Well, we're only allowed to use the first and the fourth quadrant for tangent. It's positive in the first and negative in the fourth, so we're going to be in quadrant 4. So if we rotate down pi over 4 radians or 45 degrees, our angle theta is negative pi over 4. Let's try another one. So let's take a look at x equals arc cosine of negative 1/2. So the first thing we're going to do is look at when the cosine is 1/2, and that's going to give us our reference angle. The cosine of what is 1/2? Think about your chart. The cosine of what angle is 1/2? And that would be 60 degrees. Now normally I would change that to radians, but notice it's multiple choice and they're all in degrees, so I'm not going to change it to radians. Now I'm not done. Don't choose choice 2 yet. That's not our answer, because we haven't looked at the fact that this was a negative value for cosine. So we have to figure out which quadrant we can use. Now remember, we know all students take calculus, but we're only allowed to use the first 2 quadrants for cosine because the range here was from 0 to pi. In the first quadrant, cosine is positive. In the second quadrant, cosine is negative. So we want a second quadrant angle with a reference angle of 60 degrees. So how close? So 180 degrees minus 60 degrees is 120 degrees. That's the angle that has an arc cosine of negative 1/2. So it's choice 3, 120 degrees. Let's take a look at theta equals arc cosine of radical 2 over 2, but it's asking for the value of tan theta. Ooh. So first thing is we have to find theta. So remember, theta is the angle whose cosine is radical 2 over 2. So what angle has a cosine of radical 2 over 2? That would be pi over 4 or 45 degrees, depending on whichever you like to think about. That means that tan theta that we're trying to find is really the tangent of 45 degrees. And again, if you look at your chart, the tangent of 45 degrees is 1. And you're done. Now, y equals the sine of arc cosine of 1/2. So we're going to do inside the parentheses first. What angle has a cosine of 1/2? So if you go back to your chart, cosine of 1/2, that's 60 degrees. So we're really looking for then y equals the sine of 60 degrees. Now, again, it's on your chart. What is the sine of 60 degrees? Oh, that's radical 3 over 2. There's our answer. One last one. The cosine of the arc tangent of 1. So again, we're going to do the inside first. I'm going to bring down my cosine in my parentheses. Arc tan of 1. What's the angle whose tangent is 1? So we go back to the tangent, find the 1, look up. The angle is 45 degrees. So this is the cosine of 45 degrees. Now again, what's the cosine of 45 degrees? That's radical 2 over 2. And we are finished. All right, that's it, guys. So go step by step, one piece at a time, inside parentheses first, then work outwards. And again, the key is those special angles and their trig values. You have to know them or have that chart right there open, ready for you to look at. Okay? All right, guys, have a good one.